last reaction of ester with alcohols now. And basically what that means is you are replacing the OR group with another OR group by using, of course, a reagent that is alcohol. So that's called transesterification. So the conversion of one ester into another by reaction of an ester with an alcohol is known as transesterification. So it's important to read this. It says alcohols are poor nucleophiles. So acid or base catalysis must be used. The mechanism is the same as the two ester hydrolysis mechanisms above, except that ROH is used instead of H2O as a nucleophile. We're not going to do the mechanism for this reaction. I just needed to predict the product. All that's going to happen, it's a very simple reaction, is that you're going to take this OR group and replace it with this OR group. So we generally say this is OR1 and this is 2, just to put a distinction between them. So the product then is you use tosic acid, would be the following. Plus so again, this was a leaving group and this was added. Now, how do you, I know there's a lot of space here, but how do you drive the reaction toward the product? Same as we said before. Number one is you have excess alcohol. So you add, to drive the reaction, you add excess of this. And now what is the other one? What do you think is the other one, as we did before? Is you start removing this. Remove as it is formed. Remove the alcohol product here. The final reaction for esters is called aminolysis. And in this case, what you're doing is you are converting the esters into an amide, So what's going to happen here is you're going to replace the OR right here with the amine group, of course, minus NH. But once again, you need excess CH2, CH2, and CH3. Again, you need an excess here because you're going to need to deprotonate one of the H's on the nitrogen atom. Now, the next set of reactions involves carboxylic acids. It's a very, very important functional group. So you may predict that carboxylic acid could be easily converted to esters using acid-base catalysis. We already talked about how to drive the equilibrium, and that they could be easily converted into amides. The only reaction that works is acid-catalyzed esterification. So there's a problem here. Talked about only the acid catalyzed the hydrolysis, And we may actually prematurely expect the carboxylic acid to easily go from here to there. Very easy, right? That's the prediction. But as you know in science, you can make a hypothesis, you can make a prediction, but it may not be true. The data surprises you, and then you'd have to go back and revise your hypothesis and then test it out again. So in this case, the prediction is that this is an easy pathway, but the results is the amide not formed. So let me write this. And for a very simple reason, here it is. So if we take the carboxylic acid and react this with ammonia to replace the OH with the amine group, NH2, we actually get to this point. We form a carboxylate. And for a very simple reason. So before we tell you the reason, so let's actually write why it stops here, because carboxylate is the most stable of all carbonyls. So if you recall the stability of the carbonyls in that graph, let's actually go back up right here on page, on the third, let me see which page is this. On the third page, the carboxylate anion is the most stable. So what actually happens is instead of going from the carboxylic acid to the amide, you go to the carboxylate anion, and then the reaction stops. Here is why. This is acidic. This is basic. So what's going to happen is an acid-base reaction that's going to, so instead of the attack happening at the carbonyl, it's going to happen at the acidic proton. So it's going to be like this. And then reaction stops. So obviously I just explained it here. Here it is done also if you would like to redo it in that. So let's actually redo it because it's a little bit nicer and cleaner here. So there we go. Let me use a different color. Okay, so this is a bad electrophile, we said. It's the most stable. And of course, you also have NH3 is not strong enough to attack carbonyl. And we just said it, we summarize it right there. So the reaction won't take place. Now, your book may give you an example of using some novel, a novel reaction. But again, just in general, the reaction won't take place. It's a very, very bad reaction because, again, you're making carboxylate anion, and that is the most stable, least electrophilic of the carbonyls.